Okay, so the next part says describe the horizontal and vertical cross sections through the middle of each figure, but we are just going to focus on the horizontal. Okay, don't worry about the vertical. We're just going to focus on the horizontal. Okay, so we're trying to envision what shape would be created if I slice through the middle of this object. So if I slice through the middle of this object with a plane, you don't have to sketch this whole thing if you don't want to. It's going to make what shape? A circle. Is that circle congruent to the base? No. Okay, it's not congruent, but what is it? Similar. Very good. Okay, so when you slice through or have a cross section that is parallel to the base, it creates similar shapes. So makes similar shapes when parallel to the base. Okay, on B, I'm not going to draw the plane, I'm just going to draw the shape that's going to come about once I slice through the middle. And what shape is that? A triangle. Is it congruent to its base? Yes. Okay, C, I'm going to do the same thing. I'm going to draw the shape that emerges once I do a cross section horizontally. And what shape is that? A hexagon. Is it congruent to the base?
Yes.
Yes. And the last one is, what shape is that? A rectangle. Is it congruent to its base?
No.
No, what is it? No, it's similar. Okay, so looking at A, B, C, and D, what conclusion can we make?
That if it's a pyramid or it has a point, it's going to be similar.
Very good. So if it's a pyramid or a cone, the horizontal cross sections are going to produce similar shapes. If it is a prism of any sort, what is going to happen? Or a cylinder, it's going to be congruent to its base. Very good. Okay, that's all we have to know about cross sections. Are there any questions? It's pretty simple, right? Okay. The next thing we're going to do is focus on finding 3D diagonals. So, for example, maybe finding the length from that corner to the bottom corner of that floor. So, slicing my object diagonally. Okay. Draw the rest of your box, or your rectangular prism. It'll just be easier for you to see. Okay, I'm going to give you a hint. In order to do this, you need to use Pythagorean theorem. But how do you suppose that we could find the length of this diagonal? Yeah.
Maybe you do like both triangles like that, or like multiple planes, and then add them together and then do this from the curve. I don't know.
Yes.
The plane that's the base. Find the diagonal of that first.
Very good. So if you find the diagonal of the base first, that diagonal then becomes what? A leg. Because then do you see the right triangle in here? Whoa. Every time I turn Camden, I see, like, there's something tall. So I just think that it's like a hand. And I, like, look at you every time. Okay, so you're going to have to essentially do Pythagorean theorem twice. Okay, you need to use Pythagorean theorem to find the diagonal of the base. And then using the height and this diagonal, those two become your legs now. And you're using Pythagorean theorem again to find the hypotenuse, which is your diagonal. Okay, so we're going to practice. Problem 1, the word problem is on the front, and then the problem itself is on the back. But the dimensions of a rectangular box for long stem roses are 18 inches in length, 6 inches in width, and 4 inches in height. Determine the maximum length of a long stem rose that will fit in the box without bending the rose's stem. So if I have a rose in a box, okay, can we agree that the longest distance is that diagonal? So if I have a 15-foot rose, I'm probably not going to be able to stand it up straight in a box unless my box is really tall. I might not be able to stand it or lay it flat if my box isn't very long or wide. Okay, so the diagonal is going to be your best chance when you're trying to fit a large object in something. Okay, so here's our 3D box. Okay, now it wants you to draw what the diagonal would look like, so take a second and do that. Helps sometimes to draw the right triangle. Okay, it's a 3D diagonal, so hypotenuse and the edge of the rectangular solid is a leg of the right triangle. Where is that second leg again? The diagonal of the base. Okay, so it wants us to determine the length of the second leg. So we know this is 18, we know this is 6, so let's figure out the length of the second leg. And round to the nearest hundredth once you've done so. To the nearest hundredth, what did you get? What is it? To the nearest hundredth? 18.97. Very good. Oops. Okay, now it wants us to find the length of the 3D diagonal. Okay, so you technically have 18.97 squared, but what do you know that this value should be? When I square the second leg, what should I be getting? 360. Okay, so again, you have a squared plus b squared equals c squared. You know that 18.97 that you got should be 360 plus 4 squared equals c squared. So 376 equals c squared. What are you doing?
It's like something is buzzing. It's like driving me crazy.
Alright, what do we get for the 3D diagonal?
19.
Very good. 19.39 inches. Don't forget your unit. Okay, so that method will always work. Okay, double Pythagorean theorem. But, as always, there's an equation that can be used to make life easier. Okay, so in the event that you have the length, width, and the height of a prism, you can just use the formula. Okay, and that formula is d squared equals a squared plus b squared plus c squared. Essentially length, width, and height. Okay, if we want just d, we're looking at the square root of a squared plus b squared plus c squared. Okay, again, a, b, and c is just like saying length, width, and height. Okay, so looking at problem 2, your new part-time job with the landscaping business requires you to transport small trees in your car. One particular tree measures 8 feet from the root to the top. The interior of your car is 62 inches in length, 40 inches in width, and 45 inches in height. Determine if the tree will fit inside your car. Okay, so it's a yes or no question, but you need to make sure you have work to justify your answer. Okay, so let's use our formula and substitute in. D equals, what am I going to put underneath my radical? Very good. 62 squared plus, what is it, 40 squared plus 45 squared.
Will it ever not give you, like, one of them? Or does it always have to give you 3?
It would have to give you 3 in order to use the formula. Now, obviously, they ask you for the length of the second leg. This isn't going to work. This is strictly for the diagonal. Okay, so what do you get for the diagonal? Bacon boy, what do you get for the diagonal? Bacon. Where did you get that? And it's like an umbrella. What did you say, Justin? 86.42 inches. Okay. The question is, will the 8-foot tree fit inside? So what am I going to have to do? Convert. So 8 feet times what? 12 is how many inches? 96. Okay, so will my 96 inch tree fit in my car?
No.
No.